Today we're going to learn how to graph linear equations using a table of values. So first we were given a function, and to the side here we're going to create a function table. So I'm just going to go ahead and do an x, draw a line, then I'll write my function. It's going to be y equals x plus 5, draw a line, and then put my y here. So I've created my table. From here, I'm just going to fill in some values for x. We're going to do 0, 1, and -1. And we only need 3 points to draw a line on our coordinate plane, so that'll be enough. From here, we're then just going to substitute in these values into the function and solve for y. So starting off, we are going to have y equals 0 plus 5, which gives us 5. Second, we have y equals, instead of x, we're going to put that 1 there, 1 plus 5, which will give us 6. Next, we have y equals -1 plus 5, which will give us 4. So now that we have our values, we can go ahead and plot them on our coordinate plane. First one being x is 0, which means we don't go left or right. We're just going to go up to 5. So 1, 2, 3, 4, 5. Our first point is here. Next, we have 1, 6, which means we're going to the right 1, and we're going up 6. So our second point should be about here. Lastly, we have -1, 4, so we're going to go to the left -1, and then go up 4, which would be about right here. From here, we can just connect the dots, forming a straight line. And again, we know it's a linear function because linear just means straight, and so we have a straight line. Here's another example. We have our function written above. Again, we just need to choose some values for x, substitute them into our function, and then figure out what y is equal to. For this one, again, I'm just going to choose the numbers 0, 1, and -1, and then we're just going to substitute those in. So rewriting our function, y is equal to -2 times x. First one, x is 0, so that's going to be a 0 plus 5. We solve. 0 times anything is 0, so that will just be 0 plus 5, which is going to give us 5. So we have our first ordered pair. Second one, again, we're going to substitute that 1 in for the x, so y is equal to -2, this time times 1, plus 5. 1 times -2 gives us -2 plus 5, which will give us 3. Last one, -2 times -1. Negative times a negative is going to give us a +2. +2 plus 5 will give us 7. So again, now we have our list of ordered pairs. We can go ahead and put them on our coordinate plane. So our first one's at 0, 5. So we're going to go, starting at 0, go up 5. 1, 2, 3, 4, 5, right there. Second one, we're going to the right 1, up 3. So that should be about here. And then for our x, we're going to go to the left -1, and then up 7. So I need a couple extra points here. So roughly that's what my line is going to look like. Again, it's not perfect because I'm not using graph paper, but should look something like that. So this one looks a little bit more complicated because we have a fraction in here, but we're going to solve it the exact same way as before. Again, just starting by choosing some values for x. I'm going to choose 0 because 0 is always an easy one. Whenever there's a fraction, I always like to choose the denominator for x, and then let's do a negative denominator as well. So again, since the denominator of this fraction is 2, I chose 2 and -2. You can choose whatever numbers you want. I just feel like that's always easy for me. So let's solve these out real fast. Starting off with 0. Again, we're just going to substitute the 0 wherever we see that x. So we have -5/2 times 0 plus 1. We all know 0 times anything equals 0. So this is just 0 plus 1, which is 1. So now we have our first ordered pair. Moving on, let's do the 2. So y equals -5/2 times 2 plus 1. So for this one, the divide by 2 and the multiply by 2 will cancel each other out. So we can go ahead and just cancel those two. That just leaves us with a -5 plus 1. -5 plus 1 is going to give us a -4. So let's get rid of that. Lastly, again, see, that's why I like to choose the denominator as one of the numbers, because then you can just cancel them out and it's easy. And then for the last one, we have y equals -5 over 2 times -2 in this case. Again, we're going to be able to just cancel out that denominator. But in this case, so our 2 multiply by 2 and divide by 2 will cancel, and also since they're both negative, the negatives will cancel as well. So that leaves us with a +5 plus 1, and that's going to give us 6. Okay, so now we have our pairs. We can go ahead and put them on our coordinate plane. So we have 0, 1 as our first stop, 2, -4. So let's go over 1, 2, 1, 2, 3, 4. So about here. And then -2. So 1, 2, +6. 1, 2, 3, 4, 5, 6. So about here. Okay, so we've plotted our points. And you can see our line. Okay, that wasn't great, but about like that. Okay, so this is going to be our last example for the day. Notice this one's a little bit different because in the past couple examples, it always said y equals. This one, x and y are both on the same side together. Even though it looks different, we can still solve it the exact same way, but maybe just a little bit differently. I'm going to start by choosing my x as 0. And I'm going to go ahead and rewrite. So 3 times 0 plus 4y equals 12. So when we do that, 3 times 0 will give me 0. 4y equals 12. We can divide both sides by 4. 12 divided by 4 will give me 3. So my y is going to be 3. From here, I'm actually going to do things a little different. Instead of choosing an x value, I'm going to choose a y value. I'm going to make my y 0 now and see what happens. So instead of substituting the x in, let's substitute the y, and we're going to do 4 times 0. So we put 0 where the y was this time. So we did the x as 0. Now we're doing the y as 0. Let's see what happens. So 4 times 0 gives me 0. 3 times x gives me 12, which means I can just divide 12 by 3, which will give me 4. So when x is 0, y is 3. And when x is 4, y is 0. So we've already got 2 sets of ordered pairs, or 2 coordinates here. Let's just choose one more number. Let's do 1. 1 is always a good one to do. So if x is 1, again, you can choose whatever number you want. There's an infinite amount of possibilities here. So let's rewrite. We're going to do 3. X is 1 this time, so let's put a 1 in, plus 4y equals 12. 3 times 1 gives me 3. I'm going to have to actually solve this out like a normal problem at this point. So this is going to be 3 plus 4y equals 12. We're trying to solve for y, so we need to subtract the 3 from both sides. That's going to give me 4y is equal to 9. Ooh, maybe 1 was not a good option because this is going to come out to be a fraction. We divide, and now I have y is equal to 9/4, or 2 1/4. Ew, that's kind of funky. We can use it still, but definitely not the prettiest. It's always best if you can choose a number that's going to come out nice and even, but in this case it didn't, and that's okay. We'll still use it. So from here, let's put our ordered pairs on our coordinate plane. First we have x is at 0, y is at 3, so we're going to go 1, 2, 3. That'll be about here. X is 4, y is 0, so that means we're going to go to the right 4. 1, 2, 3, 4, so be about there. And our last one, this funky one, let's see if we can figure it out. X is going to be at 1, and y is going to be about 2 1/4, so about right there. And you can kind of figure out where it's supposed to be because this is supposed to be a straight line. These are linear equations, so we know it's going to be about right there. So we connect our dots, and we draw arrows on the end of our line because it shows that this is going to continue on forever into eternity. Like I said, there's an infinite amount of possibilities. We only plotted 3 of those possibilities, but this could go on and on forever. Anyways, so that is it. I hope this was helpful to you and that you're able to complete your problems now on your own.